This is our sensor coordinator, and inside that sensor coordinator we have three different sensors. We have one temperature sensor, and one humidity sensor, and one light sensor. Now this machine is one node which is running SensIaaS asset, SensIaaS dashboard, and this is the SensIaaS dashboard browser interface, and it is also running OpenStack Glance for storing the images. And it's running the MongoDB, and it's running MySQL database. This is our dashboard, and we're showing all the physical resources that are listed here. This is one physical machine, and this is one coordinator. This is the sensor coordinator. So this is a computation bucket, and this is a sensing bucket. So this physical machine has one physical CPU and one physical memory, and we have one temperature sensor, one humidity sensor, and one light sensor inside our coordinator. And all these physical resources have been registered in our SensIaaS asset. Now we're trying to request for resource. Resources are requested in terms of groups. So we have a number of groups in our request, and we can have many types of groups. Like one is computation group, and we can have some sensing groups as well. So let's first add one compute group and one sensing group. So we're choosing the accumulator scheme. So in our computation group, we're adding one CPU, and we're adding one memory. We're adding temperature sensor in our sensing group, humidity sensor, and a light sensor. We can have many different groups, like we have one compute group and one sensing group. We can have one compute group and many other sensing groups. This n number of groups makes one entire request. So these two groups are making one request here. So we are requesting for this resource. After we have requested for the resource, we can see one virtual machine that has been created. So if we describe that virtual machine, we can see one virtual CPU, virtual memory, and vport. This virtual CPU is related to this physical CPU. This vport is related to three different sensors. It's related with the temperature sensor, humidity sensor, and the light sensor through an accumulator. We can now see how the virtual machine is running on the compute node. So let's go to the physical machine where the VM is running. And we see the VM that starts up. This is a new VM that has been created for hosting that resource. Let's log in that VM. So the VM is up. So let's see what are the virtual devices that has been allocated with this virtual machine. So let's cd2/. Like any other devices in Linux systems, we have sensors inside this virtual machine. So we can see exact EUID of the virtual device that we have shown in the dashboard. So as it's just a character device in our Linux system, so we can open it like any character device. And sense data is pumped as a binary string, so we can see it in hex. All three physical sensors are pumping 32-bit unsigned integers, and this three data is concatenated together and passed through this accumulator. So we can see this in this hex dump that each 4 byte is one data from a sensor. So one of them is temperature, and one of them is humidity, and another one of them is light. So we have a simple C program to read the sense data that is coming from the accumulator. So let's run it. So we can see the temperature data, the humidity data, and the light data that's coming through that accumulator. So, and for accessing this data, we do not need some REST or some MQ or any application level push or pull for fetching the data, for fetching the sense traffic. So what we are doing is we are just reading from a device. So let's see what we have in our C program. We are just opening the device. We are having a struct that has one temperature, one humidity, and one light. Then we are making a loop to read the data, and then we are printing. So with this facility, one SaaS developer can concentrate more on his business logic rather than concentrating on sensor application interaction, because sensor application interaction is just one read system call. We have already requested for one virtual machine. Now we are requesting for another virtual machine. So let's create one compute node, and this time let's ask for one singular. Let's add the CPU. Let's just have the temperature sensor. So let's have our second consumer VM that have only one temperature sensor and other computing. So now we can see that we have another virtual machine that has come up, one vport. There's the first virtual machine, and the second virtual machine. Oops. This is the second virtual machine that has one vport and that uses one temperature sensor only. Let's now go to the compute node to see how the VM is getting up. Let's now see how the second virtual machine, the second consumer VM that is being created. We can see this is our second virtual machine. Let's come up. This one is our first virtual machine, and this is the second VM. Done. So let's see what are the vports that has been created for this virtual machine. So we can see there is one vport that has been created. Now, if we just cat this character device, we can see the temperature data that's streaming has reached this virtual device. It's showing it in hexadecimal. It's better to read them as with a simple C program. So let's use that C program that we have used previously. So we now have one temperature sensor that is shared between two virtual machines, but the humidity sensor and the light sensor is being fed to the first VM, not to the second VM. We can see once the VM is up, it's turned green, and now we can see the sharing of these sensors here. This is the temperature sensor that has been abstracted by the physical device as a physical device inside physical machine by PPOV, and this device is being shared by two vports of two virtual machines, and these are the humidity sensor and the light sensors.